Good morning, students. In today's class, we'll learn about some more types of chemical reactions. In the previous class, we have already discussed about the two types of chemical reactions. They are chemical combination reaction and chemical decomposition reaction. And three types of chemical decomposition reaction: thermal decomposition, electrolytic decomposition, and photolytic reaction. Photochemical decomposition we have seen. Now in today's class, remaining types of chemical reactions we will see. So, chemical displacement reaction. What is chemical displacement reaction? Displacement is nothing but where one element displaces the other element from its compound. So in displacement reaction, one element displaces another element from its compound. For example, I have written two reactions here. First reaction is the reaction between zinc and hydrochloric acid. When the reaction is taking place between zinc and hydrochloric acid, the reaction take place between these two and we will get zinc chloride plus hydrogen gas. Okay, so in this reaction, you see, observe this reaction. Here we have two reactants, zinc and hydrochloric acid. Two products, zinc chloride and hydrogen gas. And their physical states also I have mentioned downside the symbol of that element, zinc. Here S in the bracket I have written, that is the zinc element exists in the solid state, and HCl AQ means aqueous solution state. Zinc chloride exists in the aqueous solution state and hydrogen exists in the gaseous state. Okay, now these two are the reactants. This is the element and this is the compound. So in this compound we have hydrogen and chlorine, two elements are there. Now zinc is the element which is actually more reactive than hydrogen. Therefore, this hydrogen, as it is less reactive element, it is displaced by zinc. So when hydrogen is displaced by zinc, then we get zinc chloride. And this hydrogen is released in the form of hydrogen gas. So in this reaction, one element is displaced by the another element. That is, hydrogen is displaced by zinc. So hence this reaction is called chemical displacement reaction. Due to this displacement of hydrogen by zinc, we get two different products, zinc chloride and hydrogen. Similarly, another example, iron, reaction of iron and copper sulfate. In this reaction, these two reactants are there. So in this is the compound. In this compound, the metallic element is copper and here the metallic element is iron. So in between these two metals, iron and copper, if we compare the reactivity, as iron is more reactive element than copper, so copper is displaced from its compound copper sulfate by iron. So from copper sulfate element, this copper element is displaced by iron as it is more reactive. Always remember children, in displacement reactions, more reactive element only displaces the less reactive element from its compound. So as copper is less reactive, it is displaced by iron, and so that we get FeSO4, iron sulfate plus copper is released outside. So these two products we will get. So these two examples are the chemical displacement type of reactions, as there is displacement of one element by the another element is taking place. Okay, next another one is double displacement reaction. Here also displacement is taking place, but the two elements are displaced. That means exchange, we can say exchanging of radicals. So if two reactants exchange their constituents chemically and form two products, it is called as double displacement reaction. Two reactants exchange their constituents. For example, in the first equation, sodium sulfate plus barium chloride. So sodium sulfate is one reactant and barium chloride is the another reactant. Both reactants should be taken in their aqueous solution state. If we take them in the solid state, there will not occur any reaction. So we have to take aqueous sodium sulfate solution in one beaker, and in another beaker we have to take aqueous barium chloride solution. Then add both the solutions together. What happens means the sodium sulfate, this substance decomposes into its ions. That means in the aqueous solution state, sodium ions and sulfate ions are freely moving, and in the aqueous barium chloride solution, barium ions and chloride ions are freely moving. So in between these ions, the oppositely charged ions will be attracting together. As sodium ions are positively charged, they will be attracted towards the chloride ions as they are negatively charged. So positive sodium ions combine with the negative chloride ions so as to form sodium chloride as the product. In similar way, the barium, positively charged barium ions attracted towards the negatively charged sulfate ions, and barium and sulfate ions attracts together, and therefore we get barium sulfate as the product. So here these two reactants will exchange their constituents. Therefore we get two products. Here barium sulfate is generally exists in the form of white precipitate, so that I have shown the arrow mark in the downward direction and I have written yes in the bracket. Or otherwise we can also write PPT in the bracket. PPT means precipitate, that indicates precipitate. So one is the solid product and second one is aqueous solution state. Another product is. So another example also we can give NaCl, reaction between NaCl and AgNO3, that is sodium chloride and silver nitrate. Both aqueous solutions when reacted together, we get two products, that is silver chloride and NaNO3. So in this reaction also, exchanging of the oppositely charged radicals takes place. As Na plus positively charged Na plus ions in the aqueous solution of NaCl combines with the nitrate ions as they are negatively charged, so that NaNO3 is formed as a product. Similarly, silver ions as they are positively charged, they combine with the negatively charged chloride ions so as to get silver chloride as the product, and it is also appear in the form of white precipitate. So it is the indicated with arrow mark in the downward direction. Silver chloride is the white precipitate which is indicated with arrow mark downward. So these two reactions are the examples for double displacement reactions. As in these two reactions, exchanging of the constituents taking place. Hence this is the double displacement reaction. Here not like that. Only one element is displaced by the other element, which is more reactive. Hence it is only just known as chemical displacement. Whereas this is the different one, double displacement. Exchanging of both radicals takes place here. So this is about double displacement. And we will also see another types of reactions, that is exothermic reaction and endothermic reactions. So exothermic reaction is a reaction in which the reaction which is carried out by the release of heat energy. So when the reaction is taking place, due to the occurring of the reaction, if there is a release of certain amount of heat energy, then the type of reaction is called exothermic reaction. Term wise also we can see, if we see the terms, exo means releasing outside, exo means outside, thermic means heat energy. So a reaction which is carried out by the releasing of heat energy outside, when that reaction is called exothermic reaction. Here in this particular reaction, when quicklime is added with some amount of water, then it forms slaked lime, that is calcium hydroxide. Quicklime is chemically known as calcium oxide. When water is added to this quicklime, it absorbs water and it forms a calcium hydroxide, slaked lime as a product. And in this reaction, certain amount of heat energy will also be released outside. If you perform this reaction in a conical flask or a beaker or any glass container, you can feel the hotness. You can feel the hotness because some amount of heat energy is released outside. So such type of reactions are called exothermic reactions. And completely opposite is the endothermic reaction. Endo means inside, within. Thermic means heat energy. So a reaction which is carried out by absorption of certain amount of heat energy. Thermic means heat. Endo means inside, within, taking in. So a reaction which is carried out by taking some heat energy, by absorbing some heat energy, then that type of reaction is called endothermic reaction. Example is decomposition of limestone. So calcium carbonate is called limestone. Generally it is known as limestone and it's chemically known as calcium carbonate. And upon the arrow mark we will write triangle. This triangle indicates the heat energy. If we supply the heat energy, this calcium carbonate limestone undergo decomposition, means breaks down and forms and gives two products, that is quicklime and carbon dioxide. So this is endothermic reaction, as this reaction is taking place only when you supply the heat energy. Calcium carbonate absorbs the heat energy and forms two different products here. So this is the endothermic reaction, as it is carried out only when you supply the heat energy. No heat energy, then there is no reaction. See, exothermic reaction means the heat energy is released outside. We will write the heat towards the product side. Whereas endothermic means near to the reactant only we have to write. Or we can write CaCO3 plus heat gives rise to CaO plus CO2. Like that also we can do. So these are the, depending upon the amount of heat energy, whether it is absorbed or released. Based on that also we can divide the reactions into these two types, exothermic and endothermic. So these are some of the types of chemical reactions. And in the next class we will meet with oxidation and reduction reactions. Thank you children.